question you'll have in chapter 7. So remember, so far we've talked about ellipses, parabolas, hyperbolas, and also circles. Those are the conic sections. And so parametric equations, let's define first of all what they are. Okay, parametric equations, there are two equations, and they are a method of defining a relation by using parameters. Okay, so it's a method of defining a relation by using parameters. And so there's an example of what a rectangular equation is. And then there's an example of what the corresponding parametric equations would be. And if you notice, there's two different equations. That's why we have the plural form. Okay? So I'll let you go ahead and get that down, and then we've got another slide we're going to talk about. Okay? But notice the rectangular equation is written in terms of x and y. The parametric equations, you have an equation for x, and that's in terms of t, and you have an equation for y, which is in terms of t. As you're writing that down, I want you to think to yourself, what possibly could t represent? Yep, that's right. Yeah. T actually represents time. Your time at 1, 0, 2. So when we deal with real world problems, that's what t will represent. However, we don't have to necessarily use it in terms of time to graph these first few, which is what we won't. And the other thing, when people look at parametric equations, they generally panic and think they're really tough. They're really not bad at all. We're going to go through these step by step, and I think you'll see for the most part, okay, they're fairly straightforward and fairly easy. So let's go ahead and look at what we have on the next slide here. On the next slide, now you're going to notice I've taken those exact same two equations, so you don't need to necessarily write those down at the top. Those are the exact same two that we ended the slide before. Notice I have horizontal and I have vertical. Okay, x is going to be your horizontal component, y is going to be your vertical component. That should make sense because x is a horizontal line, y is a vertical line. And so what that means is those are the horizontal and vertical components of my corresponding point. Okay, we have what is known as t is our parameter. That's where parametric equations comes from because the word is a parameter. So t is our parameter. We use parametric equations to determine where the object was at a given time. Okay, so we use to determine where the object was at a given time. And so in general, parametric equations have the form x equals f of t and y equals g of t. And so we're going to go ahead and look at an example of how we graph a system of parametric equations. Should be fairly easy. One of the things about the parametric equations, what they're going to give you is they're going to give you an interval. Okay, they're going to give you an interval here, and that interval is going to be for t. And they're going to say that t is between two values. And we don't know what those values are, but they will always give you an interval for that. And so based on that interval they give you, that's going to tell us what we're going to use to solve and to graph. Okay? And so up here you're going to notice it says sketch the curve given by each pair of parametric equations over the given interval. So where I get that table, it's not going to give you a table. Okay? It's not going to give you this table at all. I just went ahead and had this in there so that we'd have something to follow. They give us that x equals t squared plus 5 and y equals 0.5t plus 4. This is where the table comes from or is created. Okay, that's my interval. So my interval goes from -4 to +4. So you're going to notice I have everything accounted for in between there. I have -4, -3, all the way up to +4. So what I'm going to do, since this obviously is t, okay, I'm going to take each of those values and I'm going to sub them into the corresponding equation. Okay. So I'm going to sub -4 into the x equation. So if you sub -4 into the x equation, what do you get? 21. If you sub -4 into the y equation, what do you get? Try again. Into the y equation?
Oh, the y. I thought we were talking about.
Close. It's
Yes.
negative.
Negative.
No, it's -2 plus 4, so that should be +2. Okay, now we're going to sub in -3. So if we sub in -3, what do we get? 14. So what we could do is, if you wanted, we could just go through and do all the x's first. So what would -2 be? 9, 6, 5. Okay, so you obviously notice that it does repeat a little bit. Okay? The reason why it repeats on that one is because it was squared. Let's go ahead and look at the next one. If I plug in -3 into my y equation, what do you get? 2.5, good. If you plug in -2, what do you get? 3. If you plug in -1, 3.5. If you plug in 0, if you plug in 1. So you see the pattern, what's going to happen here? Okay, so now what we have is we have a bunch of ordered pairs, and we need to graph those ordered pairs. My first ordered pair is at 21, 2.
That's just number 4 is 6.
My next one is 14, oh, 6, you're right. My next one here is 14, 2.5. So I have a bunch of ordered pairs, I need to plot those. So what I'm going to do is I'm going to go by 3's down here. And I'm just going to go ahead and go by 1's on the y. And I need to plot each of those ordered pairs. So the first one will be 21, 2. So I'm going to come over here to 21 and I'm going to put a dot at 2. The next one will be at 14, 2.5. So that's going to be roughly about right here. The next one is going to be at 9, 3. Then I go to 6, 3.5. And then I go to 5, 4. My next one will be at 6, 4.5. 9, 5. So what do you think it's looking like? 14, 5.5. And then my last one will be at 21, 6. And it actually is a parabola. Okay, it's a parabola that opens, right? So once you've done that, all you need to do is go ahead and connect your dots. And that is what is symbolized by the parametric equations that are given. That's it. That's how you graph a parametric equation. Yes? So we're going to do another one just to make sure you have it down. Okay, this one's going to be a little different because if you notice here, t is between -8 and +8. So instead of actually looking at each individual point, I'm just going to go by 2's. So I'm going to go from -8 to +8 by 2's. And I'm just going to plug those values in. Now, notice that 0.25 is actually represented by 1/4. I use the 0.25 so I won't have to put in the fraction on there. So if I start by squaring -8, what do I get? Square -8, you get 64. 1/4 is 64 is. 16 plus 5 is 21. Okay, do the same thing with 6. What do you get? 14. What do you get when you do 4? 9. When you get 2? 6. What about 0? 5. What about 2? 'Ah. Okay. So now we're going to plug in -8. When I plug in -8, what do I get? Into the y equation. Close. 2. Okay. What's your next one going to be? 2.5.
3. 3.5. 4.
Okay. And so, where do these numbers look familiar? They're the exact same as the last one.
Alright, if we
Okay,
want to
these
graph
are the exact same as the last point. So once again, you would have a set of ordered pairs that you would need to plot, but we've already graphed those. Okay, it's going to be the exact same, it's going to be a parabola. So the thing here is that you can have a system of two totally different equations that end up with the same graph.
So we still grab it.
Yes, you still have to graph it, but I mean, we won't continue because obviously we've already done that. But that's how you graph parametric
So
equations.
when it says sketch, and you already know what it's going to be. Just kind of
Yeah.
put it in.
So let's go ahead and look at this. We've got two problems left that we're going to end with today, and that's it. Okay, now notice it says to write a rectangular form. So if we think back to the very first slide we looked at today, on that very first slide it said rectangular form was in terms of x and y, there was no t. So what we're going to have to do is we're going to use substitution here, something that you've seen before. So I'm going to start with my x equals equation, and I'm going to solve that for t. Okay, so I end up getting negative 1/3 x to equal t. Where do you think I'm going to put that?
in your life.
In the y equation. So I'm going to take negative 1/3 x and I'm going to place it right up here for t. So I end up getting y to equal negative 1/3 try again. What did I forget? The x. Negative 1/3 x quantity squared plus 2. So now all I need to do is square each of those. So if I square negative 1/3, I get 1/9 x squared plus 2. And there you go. That is writing it in rectangular form. So all you did is you go to the x equal equation, solve it for t, plug it into the y equation. Okay, what you do here is you distribute that squared to each of those individual terms. So you end up having 1/9 x squared plus 2. Let's look at another one of those before I let you loose on your homework. Okay. So x equals t squared minus 5 and y equals 4 times t. You could. Okay, the question is, could I just solve into the y equation? Could I solve this for t? Yeah, that'd work. If you would want to do that, you could do that. And take y over 4, plug it in right here. So you end up getting x equals y over 4 quantity squared minus 5. So now what we need to do is we end up getting x equals y squared over, or 1/16. Try again. 1/16 y squared. Let me write that again. 1/16 y squared plus, minus 5. That would work. Okay. If you wanted to solve it for y, what you could do is add 5 to both sides and you would have x plus 5 equals 1/16 y squared. Okay, what you would do then is do what? Multiply by 16, very good. So you would end up having 16x plus 80 equals y squared. And then to solve that for y, square root of, important thing to remember is both the positive and the negative. 16x plus 80. Okay, so anyway, either of those would be acceptable. So, not too bad? Your assignment then, page 469, 2 through 16, the evens. Okay, page 469, 2 through 16, the evens.